Gobble, everyone. Gobble. Happy Thanksgiving, everyone in America, celebrating the time the Pilgrims forgot how to grow their own food and nearly starved to death.
Good times.
Very good times. And to celebrate, we're going to talk about space missions that I think are pretty cool that have been proposed, because that has everything to do with the Pilgrims coming over to Massachusetts.
Yep, definitely. Space is a lot like Massachusetts. I've never been there.
I've never been there either. What's in Massachusetts?
Massachusetts.
Boston?
Harvard?
Those places are kind of important. Yeah, places I'll never go.
Yeah.
Hi.
Who needs them?
Hi, I'm Paul, the pilgrim-fed astronaut. And you are...
I'm Face of Sarcasm, and I am here.
I thought you'd say something
Gobble,
like...
gobble, everyone.
I thought you'd say something like, I'm the face of prayer or the face of sin or something like that, to go with our Thanksgiving and pilgrim theme.
Nah, I don't care about those guys. I have a buckle on my head. Does that count?
That's because of the accident.
Oh. Dang it.
Yeah. Well, this is just special I thought up while pretending to work. Totally working at my job. I wanted to talk about, because we talk about missions that have happened, and we sometimes talk about missions that could have happened, but then became missions that exploded, right?
Mm-hmm.
And I figured, why not talk about missions that I think are pretty cool, that have been proposed or are proposed, that I think would be neat to see happen.
Okay. Yeah.
Including
cool.
the one in the thumbnail image here.
It's a pretty cool image.
Which I made in Blender.
Nice. Good job.
So this one, we're doing the outer solar system because, okay, Mars is nice. Mars is interesting. Humans should go there. Exploration's nice. I would like to see the outer solar system more, though. I think that's way cooler.
There's way more stuff in the outer solar system.
Yeah, you got Jupiter here. Look at that. That's Jupiter.
Ain't gonna see another planet like that one.
Well, kind of. It is a gas giant, so...
Yeah, there's a few more of those, but you know what I mean.
Yeah, Jupiter,
right?
The king of the planets. It's 70,000 kilometers across, or 44,000 miles. It's really big, because it ate all of that turkey. Happy Thanksgiving. We're recording this the first week of October.
Yeah. Oh, I saw Christmas lights at Target the other day.
I saw Christmas lights last month.
We have to stop the encroachment of Christmas.
We haven't had Halloween yet. And, of course, you, the listener, have already had Halloween at the Dead Space 2 live stream, which I assume all of you went to, and it went really well.
It was so amazing, I assume.
Yeah, we're talking about one of the planets we're not going to in this episode. Saturn. So Jupiter's, of course, 5.2 AU out. Its year is like 11.86 years on Earth. It's Jupiter. It's the big one. We just went there with Galileo several years ago now.
Yeah. Just happened. Totally.
The mission I'm talking about wanted to go there about 20 years ago also. So this is Jupiter Icy Moon's Orbiter. And you heard me correctly. Orbiter.
So it's going to orbit the moons.
Yes. Now, to do that requires a really, really big spacecraft. Okay? So the plan was to orbit Callisto, then go to Ganymede, and then go to Europa.
I guess not Io.
No, it's not icy moons. Not sulfuric. Icy.
Yeah, but like Io's there, it feels like you're doing the 3 of the 4 Galilean moons. We don't want to leave Io out,
Yeah, everyone went to the party except you.
We invited everyone else except you.
Yeah. So this is actually part of something called Project Prometheus.
Ooh, that sounds fancy.
So right now, deep space spacecraft are powered by RTGs, right? That use radiation from plutonium decaying to generate electricity to power the spacecraft.
Yes.
But those are just there because solar panels don't really work out very far.
Inverse square law is your enemy at this point.
And these spacecraft operate at about 700 watts at the beginning of their lives. Voyager's running on, like a battery's worth of power right now.
Right. Yeah.
These would use gas-cooled Brayton cycle nuclear reactors to power them. We'd put an actual nuclear reactor into space. Kind of like the Soviets. And Snap 10.
Yeah, we did Snap 10, yeah.
The Soviets also orbited several liquid metal-cooled reactors.
Okay, that's awesome.
We'll do
that's metal.
Oh, it is. Sodium. And potassium. Yeah. We'll talk about those when we do Roarsat, because one of them hit Canada.
Oh, good.
Oh, yeah. And they just spray debris into low Earth orbit.
That's what you want your nuclear reactor to do.
Yeah, that's a fun thing to do. So these reactors would be 200 kilowatts of power.
Oh, gosh.
To put this into perspective, before we started putting the rollout solar arrays on the ISS, the full ISS solar arrays could do 150 kilowatts. And these would power high pep ion thrusters. Because, again, if you want to enter orbit of these moons, you need a lot of propellant if it's standard chemical propulsion, or a really powerful ion engine if you're using ion thrusters.
Yeah. So going with ion makes a lot more sense.
Yeah. Again, this would actually enter orbit of these moons. And then leave orbit.
That's awesome.
It is really cool. So, for reference, this weighed 36.375 metric tons.
Yeah, it's pretty light.
It's a lightweight thing. So put this into perspective, I think the Orion capsule weighs 26 metric tons.
So it's big and heavy.
Yeah. The heaviest Apollo mission, which is I think Apollo 16, was 50 metric tons.
Okay, so it's not that big, not that heavy.
It carried 12 tons of xenon. Most of these spacecraft we talk about carry less than a ton.
Oh, okay.
Yeah, I remember when I did Cletus, we were looking at how much xenon we need for the Argon thrusters to resupply Mars missions with xenon to go to Mars, and we determined we'd end up using about 3 to 4 times that, so about like 50 metric tons, which is somewhere around a third to a half of the global xenon supply annually.
So not much.
Not much. So to put this into perspective for the size of this spacecraft, it is 58.4 by 15.7 meters in size, or 192 feet long, or 52 feet wide. So it'd actually be it'd be stowed. It'd actually have to fold out of itself. And for the ejection, they'd actually have to launch 2 Delta cryogenic second stages to dock with it to boost it out.
Gosh.
Let's check.
Oh my gosh.
So the original launch dates, because again, this was a 20-year-old, this mission was proposed 20 years ago, would launch either in 2015, 2016, and 2017. About 10 years ago.
Oh, so that's coming up. That's coming up.
It would enter orbit of Callisto, since it's the outermost, on February 17th, 2022, which we all know happened.
Mm-hmm.
It would enter orbit of Ganymede in December of 2023.
Definitely remember that.
I remember that. And it would be orbiting Europa right now.
That's why we're talking about it.
Which is why we're talking about it, yes. As compared to Europa Clipper, which will get there, I think, in like 2028 or 2030. I know Juice is going to get there in 2030.
Cool.
Yeah.
It's beating these guys.
And it's not even going into orbit.
Like, what even is the point?
What do you do? You need a 36 metric ton spacecraft to do this.
Yeah, come on. Like, let's be real. You gotta go with the 36 tons.
It would only cost like $16 billion.
We have that kind of cash.
We have that cash line. Yeah, that's a good cash line run. That's a launch vehicle development program right there.
Yeah. Pretty simple. Yeah.
But it's a really cool mission, I say.
Yeah, definitely worth it.
Yeah, and so this right here, by the way, is a ground-penetrating radar antenna.
Oh, I thought it was to try and get cable.
That too. You gotta listen to the Europa, tunes in the channels.
Yeah.
So that, again, it's basic sensor suite, just way more powerful. Because again, you have a radar that could actually like probe below the surface of Europa to see like if there's a subsurface ocean or not.
Yeah, it's like in 2010 when the
Yeah.
Leonov's going over. Yeah.
Exactly. Really big spacecraft, though. 200 feet wide, long, 50 feet wide, 36 tons.
Yeah.
Really cool mission. And it never happened, of course, which is, I'd say, a travesty.
I mean, it would only cost $16 billion. I mean, come on,
We have that lying around.
we have that kind of cash.
So I want to go out in the space between gas giants.
There's space between gas giants.
Yes, there is. A little bit. It's an alley.
How much space?
Well, there's enough space to have asteroids out there.
Ooh.
So, right, asteroids aren't just in the asteroid belt. They're actually all over the place.
Really? Oh,
Yeah.
interesting.
And-
I thought it was just the belt and nowhere else.
Well, we've been to a few in some of our episodes. Are inside the belt. We've been to some. Outside, so between the asteroid belt and the Kuiper belt, there are more icy objects called centaurs.
Does that have anything to do with the horse people?
Yes, as you can see in this picture, that is a horse person.
Wow.
Yes. And actually, this is the biggest one we're looking at right now. It's called Chariklo.
Cool name.
And you notice there's something really interesting about it.
Is it the YouTube circle around it?
Yes, it has rings.
Dang. So good he put a ring on it.
Yes. The first centaur discovered, 2060 Chiron, also has rings. And you can see the way you discover them is, as seen by James Webb, the Chariklo will pass in front of a star, and it'll dim it. And you'll see that the starlight is blocked by the two rings it has.
Huh.
Yes.
Okay.
Yeah. And the rings actually have names. So the inner one's called Oiapoque, and the outer is called Chuy. Chuy, it's Portuguese. It's the two rivers that make Brazil. The borders of Brazil, the northern and southern border of Brazil.
Got it. Okay.
Now, so Chariklo is one of 4 objects so far that we've discovered that have rings. Chariklo, Chiron, Haumea, and I think Quawar has rings, which is pretty cool.
That's pretty hype. I like rings.
That is really cool. Which, of course, means we should probably go to one of these. Wouldn't that be cool?
That would be really neat. Yeah.
Yeah.
Get up close, get some pictures, especially those rings.
Get the wedding photos, right? It's like the big ring, It's like, oh
Yeah.
my gosh. You know the types I'm talking about, listeners.
Oh yeah.
Right? The woman's like, oh my gosh, look at this ring. And also, based on James Webb observations, there's probably water ice on the surface.
So we could drink it.
You could drink it. Yeah. Heck of a wedding party.
Yeah, we brought water.
As you can see in the spectra here from our good friends, James Webb.
Thank you, James.
Yep. So this is Camilla. This is a
Hi, Camilla.
Hi, Camilla. So this is a proposed New Frontiers mission. So it's above Discovery class, but below a flagship mission. It's too expensive to be Discovery, but it's not full scale. We're landing a helicopter on Titan type scale.
Okay. I still don't know what these mean.
New Horizons is a New Frontier mission.
Okay.
If New Horizons was a flagship mission, it would be orbiting Pluto right now.
Oh, okay.
So these are about like a $1 billion program, roughly, right? Flagship's about $2 billion. New Frontiers is about $1 billion. Discovery is less than that.
So the other one we were talking about, Jimmo, that one would have been New Frontiers.
Absolutely, it's a Discovery class mission right there.
Yeah, I know.
Yeah. So this little guy weighed about 1.4 metric tons, and it performed a flyby of Chariklo or Chiron. It would launch, and it would include an impactor. Actually, this little guy down here.
Gonna go beat it up.
Yeah, we just discovered you. All right, boys, smacking time. Just like that Deep Impact.
Yeah. Was it a Bronze Age civilization on it?
Well, they have rings, so they might have Bronze Age civilizations. We got to find them.
We gotta teach them a lesson.
So the launch would be as early as September 9th, 2026, so about this time next year, as we're recording, on an Atlas V 401, and then it would do a flyby on January 5th, 2039.
It's a pretty quick turnaround.
I didn't update Chariklo's orbital data. That is Jupiter's orbital ddata.
Yeah, wait a second. It's pretty big.
Yeah, Chariklo is pretty huge. We have another gas giant that no one found. It's wearing the Groucho Marx mask, so we didn't realize it was a gas giant. Chariklo is actually about 150 kilometers across, and it's sitting at on average about 7 AU away.
So like halfway between Jupiter and Saturn.
Yeah, again, that's what kind of defines these. So on board the experiments, we'd have Halberd, the impactor. It'd have a camera with visual and infrared spectrometer. It would have SMART, the submillimeter spectrometer, because again, it's looking at the surface for surface features. It'd have a UV spectrometer, and then it'd do some radio science.
So pretty standard.
The stuff we see on all these missions. Get ready to learn about radio science and all these fun things. Almost all these missions have the same thing. So we're kind of speed through those. Again, but this is a cool mission to see, right?
Yeah. Go to a place, check out the rings, discover a giant planet that you never saw before.
And then hit it.
And then beat it up.
So this is the trajectory it would take. This is directly from the proposal paper. It'd launch from Kennedy Space Center, do a Venus flyby, do a deep space maneuver, do a flyby of Earth, keep going, do another flyby of Earth, and then I do a Jupiter flyby. And as you can see, why it needs to do big flybys, because Chariklo is at a high inclination. Oh, it's more like 18 AU. Sorry. It goes all... They're really eccentric orbits, by the way.
Oh my gosh.
Yeah. It's at a really high inclination.
Jeez. Okay.
Yeah. But this would be the first mission to a Centaur, and it's got rings, which I think would provide really cool image value to it.
That'd definitely be worth the $1 billion.
Yeah. So we're going out farther, and this is the time we should get this joke out of our system.
Anus.
Exploring Uranus. Probing Uranus. Taking pictures of Uranus.
Looking at Uranus.
I want to look at Uranus. Uranus is interesting.
Look how blue Uranus is.
Uranus is blue because of methane. Uranus has methane. Uranus has interesting moons. I want to fly by Uranus.
Uranus stinks. It smells.
Okay, Uranus is an interesting planet. Just get it out of your system. Get the Uranus jokes out. Get it out.
Why did they name it that?
It's the Roman god for... I think the Greek version is Calus. Caleus. You ever heard the phrase celestial? Like celestial eagle?
I guess not.
Like Celestron. Celestial, the heavens. That's where it comes from.
Okay.
The god of the heavens. Uranus. And you know this is what the episode's going to be titled. It's going to be called Exploring Uranus, because we are 15 years old, collectively.
Yeah.
But, you know what we're looking at on the right side of Uranus?
Well, to the right of Uranus, isn't that Miranda?
That is Ariel, actually.
Ah, it's Ariel. Dang it.
And you'll notice some interesting features on it.
It's very wrinkly.
It's wrinkly. And as of like 2 weeks ago, it's probably because there's a subsurface ocean.
Plate tectonics?
Yes. Ice plate tectonics.
Ooh.
So,
awesome.
As I said, Uranus is interesting. So, we're talking about 3 missions that have been proposed to go to Uranus. Okay?
Mm-hmm.
Now, don't worry, I actually got the details of this planet right this time. So Uranus is interesting because it's on its side also. It's at 97.77 degrees or 82.3 degrees, depending on how you want to do it. Convention system. Mm-hmm. It's on its side, which is interesting. It is 25,000.2 kilometers across, or 15,000.8 miles across. It's pretty big. It's like 4 times the size of the Earth.
About right, yeah. That's about right.
It orbits the sun at 19.2 AU, so it's really far out there. Its year is 84 years.
Yep.
So assuming I live to my estimated age of about 88 to 90 years old, Uranus will have completed at least one orbit in my life.
Uranus will have gone around the sun once.
Yes. Now, the reason why Uranus isn't talked about as much, aside from the obvious jokes you'll have to come up with, is the moons aren't that interesting compared to, Neptune's or Saturn's, right?
I mean, I guess, yeah. It's kind of boring, dark gray.
Yeah, the moons are, like, the big ones are icy, but at Neptune you have Triton, which has cryovolcanism and an atmosphere. You have Titan at Saturn, which has, like, methane lakes and an atmosphere. It might have life. Enceladus is made of ice, which might have life, right? Uranus isn't as cool with the moons as Jupiter, Saturn, or Neptune.
Yeah. Yeah. Yep, that's fair.
But it still is worth exploring because of the gas giants, Uranus has the lowest internal temperature.
It's the coolest.
It is the coolest of them. Uranus is cool. The atmosphere is, the reason it's got that blue tinge to it is because of methane. But the weird thing is the magnetic field of Uranus is not through the center of the planet.
What?
Yeah, and it's 59 degrees off the rotation axis.
What's it doing?
Don't know. There's only one way to find out.
We gotta go there. We gotta probe Uranus.
Gotta probe Uranus. God. So Uranus has 29 moons. The most recent was discovered actually this year.
Oh, nice.
Yeah. The largest is Titania, which is about half the size of the moon. Oberon, which is about half the size of the moon. Umbriel, Ariel, and Miranda. Miranda is probably the most interesting visually of the moons. I didn't get a picture of it.
It's very wrinkly.
It's very wrinkly, which is probably caused by the internal ocean escaping or freezing.
Or doing both. It escapes and then freezes.
Yeah. Yeah, there's just giant fountains. We don't know what's going on there, guys. Yeah, so Ariel probably has a subsurface ocean, and you could probably assume that Titania, Oberon, and Umbriel probably have subsurface oceans, because why not? All of them do.
They're all doing it. That's the trend. That's what the kids are doing these days.
Yeah. All the kids got subsurface oceans. They all do vapes. They all have that broccoli haircut, and they have subsurface oceans.
Mm-hmm. And they're all doing that around Uranus.
All around Uranus. God. So, also, as I've talked about before, there's a 2002 study that noted that because the ratio of masses between the moons of Uranus and Uranus itself, you could just do flyby after flyby after flyby of the four largest moons, like Galileo did.
Oh, okay.
Yeah, so it's really good on delta V, so you don't have to carry as much propellant with you.
Yeah.
And just to be clear, the last time we saw Uranus up close was in January 1986.
Isn't that the only time we've taken a good close look at Uranus?
Yes. 40 years ago.
Excuse me, it's like 39 in a couple of months.
Effectively 40 years ago, okay?
Yeah.
On a space probe where, it's got the tape deck on it still. Right? The most recent, of course, is done by James Webb. As you can see in infrared here, that's what we're looking at.
It's Uranus in infrared.
Yes. So we're talking about 3 missions here. Muse, Oceanus, and Uranus Orbiter and Probe. So Muse is mission to Uranus for science and exploration, as compared to the alternative. It's an ESA proposal, considered for New Frontiers, to send an atmospheric probe and orbiter. Shocking. Launched on Ariane 6 or an Atlas 5. It'd weigh about 4.2 metric tons, and it would launch September of next year, or November of 2029. It arrive in 2044 and 2049. That's also one of the reasons why these missions are so expensive.
I mean, you have to fund it for like 20 years. Like, seriously.
Well, you just put it to sleep until it gets there.
Yeah.
Like New Horizons or the other ones. Now, I'm just going to kind of go quickly through these because you know what all of these are. You know what all the science are. Spectrometers, thermal spectrometers, UV spectrometer, radioplasma wave experiments, fluxgate magnetometer, TULF and ELF antenna, so it's going to listen to elves make cookies, ion composition instrument, ion and electron sensor, energetic particle detector, cameras, radio science, microwave radiometer. The most important thing, a dust counter.
Dust counter. Good.
On the atmospheric probe, you have a Doppler wind experiment, atmospheric physical properties experiments, gas chromatograph, and a mass spectrometer. You have an aerosol sampling and nephelometer, right? The same stuff that flew on Galileo, same stuff that flew on Vega. You've seen these all before.
This is your probe starter package.
Yeah, this is your Galileo or Cassini style mission probe starter pack. Oh my gosh.
Wow.
Yeah, and you got a deployable Yagi antenna so you can listen to get TV channels while you're out there.
Well, yeah, you're out there for 20 years. You need something to entertain you.
You know what a Yagi antenna is, right?
Yes, I definitely do, but for the audience,
So
can you
for
explain it?
so for the audience, you see on houses they have antennas that look like this, right?
Yes.
That's called a Yagi antenna. It gets all the different TV channels.
Okay, so that's what we saw on Jimmo.
GMO, yeah. Well, that was ground penetrating radar. Yagis are specific because they're smaller than larger.
Got it. Kind of the Christmas tree, sideways Christmas tree shape.
Yeah, so that's what a Yagi
Fishbone shape.
Yeah, what a Yagi is used for. It's usually it used to be used for TV.
Yeah, I remember we had one at the house.
Yeah, I remember we cut it apart, which is a shame because I want to use it now. I would want to use it for my experiments, but so we have Oceanus. Origin.
That's a great title.
Well, it's an ice giant, right?
Yeah, why did we name the planet that?
That's a good. Well, that'd be Neptune then.
No, you name Uranus Oceanus, so you could just stop with the jokes.
You know what the original name was?
No, what was the original name?
Georgium Sidus. George's star, because that was the king at the time when it was discovered by William Herschel.
Oh,
Yeah.
yeah. Don't name it after kings.
It's not from King George. No, we don't have kings here. Okay.
No kings where I'm from.
Origin.
Just name it Oceanus.
Yeah, or Caelus if you want to go with the Greek. So this is origins and composition of the exoplanet analog Uranus system. One of the big shifts for a lot of this stuff, especially since Galileo Cassini, is now that we've discovered a lot of exoplanets, we should probably characterize what the most common look like.
Yeah, okay.
Yeah. So it's because the most common planet we've found so far are super Earth exoplanets. So super Earths or hot Neptunes. So planets that are like 4 to 5 times the size of the Earth, like Uranus and Neptune.
Oh, okay.
So the idea is, well, we have 2 in our own solar system. We should probably figure out what they're like.
Probably figure out what's going on in our own backyard before we start looking out at the neighbors.
Yeah. So this weighs about 4 metric tons. It launched in Atlas 551. It launched in 2030 and gets to Uranus in 2041. And you'll notice it looks a lot like Cassini.
Yeah, vaguely Cassini shaped.
Don't worry, they're all Cassini shaped. So it's got a magnetometer. It's got gravity, atmospheric instrument antenna there. It's got an atmospheric probe. It's also got a camera on it based off JunoCam. That's the one that takes all those really cool pictures of Jupiter right now.
Mm-hmm.
So it's got its own version of that.
Just Uno cam.
Yeah, UnoCam.
Uno reverse card cam.
Yeah. Really cool stuff. Again, these are really cool missions I'd love to see happen.
I would love to probe Uranus.
Yes, you would. Now, this is the one I really want to talk about, though. Because, so this is Uranus Orbiter and Probe.
Isn't this one we just looked at?
No. This is the new version of that one.
Okay.
So, as the formalization of space science happened in the 90s, something was created called the Planetary Science Decadal Survey. Pretty much what that is, it says, okay, for the next decade of space exploration, what should we really focus on?
Okay.
Uranus Orbiter and Probe sits at the top of it right now.
Oh, okay.
Right, because the last flagship proposal, I think, was one of the Curiosity rovers. No, Dragonfly. It's Dragonfly, the Titan, the helicopter that's going to land on Titan and fly around.
Got it. Okay, yeah, that's awesome.
Which is really cool. This is the flagship class proposal.
Okay.
It beat out Enceladus Orbalander, which, so you know Enceladus, right? It's got the cool geysers and jets of water.
Yeah, yeah.
This would be a probe that would land on it and like take samples.
Okay, that's pretty awesome.
That is really cool. But we're also sending another mission to Saturn. I think the idea is to get probes to Uranus and Neptune.
Right, because we've only ever been there once.
We've been there once 40 years ago. There's so much to see. So I actually did read through the proposal for this and how it addresses certain science concepts. If you want to see what goes into how these missions work and how they're built and proposed, do read this. It's linked in the description. It is really interesting and very detailed.
How long is it?
About 200 pages.
Okay, so it's just a small novel.
It's a short novel, yeah. You can crack that out in an evening.
Yeah.
So
just grab some wine, set up some candles, and start reading about Uranus.
I told you to get out of your system at the beginning of this.
It's never leaving. It is my system.
Oh, God. I want to write a hard science fiction novel that goes to Uranus. And and that's the biggest problem with trying to sell the book. Oh, what's it about? It's about Uranus.
So they go to Uranus.
God, we have to rename this thing.
You have to rename the planet. Honestly, Oceanus. That's my
Oceanus. I like Kalis because it goes with the naming scheme of fitting the rest of the planets. Who knew that in 1783 that this would be the butt of a joke?
I bet they did back in 1783.
It could have been, yeah. We called it this.
We named it the Butt Planet.
Yeah. So you notice the spacecraft looks a lot like Cassini. Shocking.
Yep. Yeah, it looks a lot like the last one we saw as well, as I noted before.
Which also looks like Cassini.
Yep.
So this would weigh 7.2 metric tons at liftoff, or about 16,000 pounds, which would, I think, make it the heaviest space probe ever launched.
Wow. All right. Well, I mean, it's got to eat its weenie. It's got to get all the way out to the outer solar system.
Yeah, because I think JUICE right now is the heaviest at 6.5.
Jeez. Okay.
Yeah. So this would launch June 9th, 2031, either on a Falcon Heavy or an SLS Block 1B, and it would get to Uranus on December 5th, 2044. So it would be really close to my, 49th birthday.
Oof, you're going to be 50.
I'm going to be so old when this happens. This is also one of the problems with these kinds of missions. It's going to take them how many years to get there? 13 years.
13. Yeah.
Now, this launch date assumes that funding for this mission happens now.
Okay, so you're going to be 60 by the time this happens.
We are currently recording this episode during the government shutdown, which slows these kinds of missions down.
Yeah.
As a note, we like to make space as apolitical as possible, but space programs attached to national interests are inherently political. Some groups of people don't want to fund space science. Some people do. If you like space and going to space, vote for the people who actually fund these things. Happy Thanksgiving, everyone.
Yeah, tell your uncle about this. Show this to your uncle.
Yeah, show your uncle Uranus, okay?
No, don't do that. Don't do that.
Had to get out of my system. Okay, so on board the experiments would be used leftovers from other probes. So you have the Messenger magnetometer, the New Horizons long-range camera, the thermal infrared camera from LRO, the Maven Langmuir probe, the plasma wave experiments, the Search Coil magnetometer from Tracers, Messenger's fast imaging plasma spectrometer, the Parker Solar Probe electrostatic analyzers, the Parker Solar Probe energetic charged particle detector, the very near infrared spectrometer and wide angle camera from Lucy, and then just do radio science.
So again, your very standard probe starter pack.
It's a probe. It's a space probe. It's a really big one too. That's how tall is that? 4.4, 4.6 plus 1.6. So that's what? 6.2. It's about 7 meters tall. It's like 21 feet tall.
So it's a mini bus.
It's big.
That's big.
Yeah, you'll notice that this part here is all propellant. Up here is this.
I wonder why.
Yeah, the science stuff weighs about 300 to 400 pounds. Yeah, I think the delta V capability for this is somewhere around 2.7 kilometers a second.
That looks about right.
To put this into perspective, going from low Earth orbit at from Kennedy Space Center to geostationary transfer orbit is about 2.5 kilometers a second.
So not that much.
It's a little maneuver, which is about 90% of the way of leaving Earth.
Tiny. Insignificant.
Yeah. So on the atmospheric probe, you'd have the Rosetta double focus mass spectrometer, the Huygens atmospheric structure instrument, the ortho para hydrogen detector, and then to do some radio science as well on its way in.
So other basic probe starter packs.
Your basic probe starter pack. So here's a good picture of the inside of it. Again, it looks like the one from Galileo.
Yeah. Spherical.
Yeah, spherical. And I like this mission. I actually like Uranus orbiter and probe. So this is the mission it would do. So it enters the system. You can read it really good here, right? It launched. Again, it would do Earth flybys unless you're doing SLS Block 1B, and then you do a Jupiter flyby, which would send it to Uranus, and then it would come in here and then get into orbit and do flyby after flyby. Again, a Galileo style mission, and this is kind of what it would look like.
Okay.
Or wait, it'd come in like this, actually. Yeah, because it starts out really high and then phases. Because remember, Uranus is on its side, so are the moons. So you'd actually have to phase your orbit to match that.
Yeah, that's why it's got to do this stuff.
And so it'd operate around Uranus for about 4 years.
Okay.
And we actually see all of the moons up close instead of just 40% of them that we saw 40 years ago, right? So here's Titania on the left. This is how the actual flybys they have planned, which, hey, that one's close to your birthday. Right? You know, a lot of really good science. You could see the entirety of these moons up close. Because remember what we saw with Galileo, right?
Yeah, we saw a lot.
We learned so much and knew how little we knew from Galileo. Now imagine Galileo with way better cameras and without tape recorders that break.
Like actual modern technology.
Yeah, digital technology.
Gotta have the digital technology.
So we do some aerial flybys, of course, to get...
Of aerial? Oh, yeah, sorry.
Yeah, aerial. And these are actually really close. 35 kilometers, 25 kilometers.
Oh, wow.
You'd be getting really in there.
You'd be smelling the surface.
Yeah, really close. But, to get the best science, right?
Yeah, gotta get up and close and personal.
So let's go farther.
Even further beyond.
Neptune.
See, that one doesn't have a silly name.
It does not. This is Neptune, taken by Voyager 2 35 years ago.
Which one's Neptune?
The big one.
Okay.
That's Triton.
The small one.
The small one. So, yeah. What a good shot.
That is incredible, yeah.
So, Neptune has the wrong picture in it for basically everything. So, we're talking about 4 probes. 3 of them actually have details.
Okay.
One of them is basically GMO, but for Neptune. So, Neptune isn't as blue as you think it is because of one image that was wrong. And this was...
So it's actually a similar color to Uranus.
Because it's got similar atmospheric composition to Uranus.
That makes sense.
The image that's been shared was a false color one, because the false color with the enhancements, it allows you to see more surface details, right? You can see the great dark spot, you could see more of it. The problem is everyone used that one, and that's the wrong one.
So this is the correct one.
This is what Neptune actually looks like. If we were to...
Very bright.
Why are you blue? So this one's about 24,500 kilometers across, or about 15.3 thousand miles. So it's a bit bigger than Uranus. That's about the same size. Yeah, it's slightly bigger than Uranus. It's out at 30 AU. So Uranus was 20. This is 30. So its orbit is about 165 years.
You're not living to see a year on Neptune.
Correct. Unless you really, really think hard about it.
Yeah, you just got to start drinking carrot juice.
Yeah, drink the carrot juice. Do whatever that one guy is doing. That weird guy.
Blood transfusion with his son.
Yeah, that guy is weird, by the way. We're not going to get into that because it's not the purview, but that guy's just weird.
Yeah.
He spends like...
Sorry.
He spends like 6 hours a day trying not to get old.
I do the same, but I usually just distract myself.
Yeah. There's psychology there that no one wants to address. We won't get into much into that. We'll talk about it on the Dead Space 2 live stream instead, which will have happened by now. Happy Thanksgiving.
Yeah, go to the go to the past and then go back to the future, and you should be understanding why we talked about it then.
So the thing with Neptune is, Neptune the planet isn't as interesting as, let's say, Jupiter or Saturn or even Uranus, but its biggest moon is
Yes.
Triton. Now it's actually got 16 other moons, but no one cares. Can you name any of the other moons of Neptune?
Naiad?
Nereid. Yeah.
Nereid. Yep, can't even do it.
Nereid. There's, I think, Larissa. There's another one. Proteus, I think, is the other one. Or is that around Saturn?
I don't remember.
No, again, who cares? Triton. This one.
Yeah, Triton. It's the big one, yeah.
So this is actually the southern hemisphere of Triton.
Ooh,
Yeah.
okay.
So Triton is about 78% the size of the moon. It orbits Neptune at about 355,000 kilometers, and its orbit is backwards. So it orbits Neptune backwards every 5.877 days.
That's why it's negative. It's going back in time.
Yeah, that's kind of why it's interesting, you know? It wants to go see the Dead Space 2 live stream after I uploaded it. So
wait, hold on a second. If I drive a DeLorean around Triton once every 5.877 days, I will not move through time.
Correct. You will stand still and stop aging.
Perfect. There we go.
That's what that guy needs. So obviously Triton is very interesting. Even just looking at this picture, there's a lot of really interesting features about it.
Yes.
Cantaloupe features. Right? Down here you can see geysers. Evidence of cryovolcanism.
Yeah, because that's the plumes, right? That's the streaks, yeah.
It has a tentative nitrogen atmosphere.
Ooh, okay.
There are cryolava lakes. They're frozen, but there's cryolava lakes. Again, it's water. The lava, water. Ooh. Tholins, which are just hydrocarbons.
Okay.
The surface itself is probably relatively young.
Well, yeah, if you're having active... You can see the geological features on it, right? Those look pretty recent. I don't see that many craters.
There's a few there. There's a handful of craters. So it's obviously a relatively young surface, and get cantaloupe features. Even like a lineae here, kind of like on Europa. Here. So, again, Triton is very interesting. We'll discuss it when we do Voyager for the 4th of July, 2027.
Look forward to that. Subscribe. Like and subscribe.
Go on to Triton, go to the future, like, comment, subscribe.
Well, if you go into Triton, you'll go to the past. Don't do that.
All right.
Go to the future.
Go to Uranus to go to the future. Just saying. So the last time we saw Neptune up close and personal was August 2nd, 1989.
35 years ago.
Yes. A really long time ago. Again, with, a film camera,
Yeah.
Not even digital cameras, a film camera. It's obviously worth going back to. The problem is it's really far away.
Yeah.
So the first one I looked at, I actually saw this about 20 years ago, this image.
Oh, gosh.
It was in a popular science magazine, and I thought it was the coolest looking space probe ever. I don't have that magazine anymore.
Oh.
I am so mad at myself. Oh, and I forgot to get the book I got in 2006 of proposed space probes for kids. Oh, man.
Dude, you're just dropping the ball.
I'm so old. I have Alzheimer's now.
Look, get onto Triton. Go back in time.
I'll go
get the
it.
stuff for yourself. Yeah.
And of course, as you can see, this has the wrong image of Neptune on it because it's 20 years old.
Yeah.
So this is a GMO successor. It's Project Prometheus, as you can tell.
Yeah.
Except the ion thrusters are in the wrong spot. They're supposed to be here.
Yeah, they're supposed to be over there. Yeah.
We gotta get on Triton, go back in time, tell this guy he's wrong.
Yeah.
So
maybe give him better computers to render this stuff with.
Yeah. I think the image I made has more data in it than this.
I think the slide has more data in it than this.
Yeah. So this is a relatively simple proposal. Again, it's nuclear electric propulsion. Use a 200 kilowatt Brayton cycle reactor. Weighs 36 tons. It'd leave January 2016. Do a Jupiter gravity assist. And it'd be at Neptune in January of 2029.
Just fork over 16 billion. You know, like we have the cash.
$1 billion for every year it's in space. Yes.
Yeah, exactly. We could afford that.
And since this thing is so awesome, it would also carry an atmosphere probe and a Triton lander.
Oh, okay, that's awesome. Oh, that's the time machine.
That's your time machine, yeah. And this looks like the landers I make in Kerbal Space Program, by the way. It's a little hexagon, a little octagon, or hexagon. Yeah,
Hexagon. It's 6. Yeah, hex.
Yeah. I make little landers that look like that in Kerbal Space Program. I've got one heading to, what's the equivalent of Neptune in Outer Solar System expansion?
Is it Nereid?
Something like that. But yeah, it's got your standard experiments. Spectrometers, radio science, plasma waves, altimeter, magnetometer, radar.
Cameras, yeah.
The lander would have a surface science package, cameras, spectrometer, sampler, which that'd actually be really cool to get pictures from the surface of Triton.
That'd be sick.
You got a graph.
That's worth the 16 billion.
Of course it is. It's always worth it. Science is cool. It's worth it. Mm-hmm. You got a gas chromatograph, mass spectrometer, atmospheric structure instrument. Because again, it's got an atmosphere, theoretically.
Yeah.
And the atmospheric probe is basically the same one you'd see on Galileo. You saw on Uranus Orbiter probe. It's the standard atmospheric probe.
Very standard, yeah.
Yeah. Again, I'm really mad that I didn't... Because I remember the concept art looked different. It looked more like Gmo than this. I'm sorry. Again, I'll hop onto Triton and go back in time.
There you go.
So then the next big one is Neptune Odyssey, which looks like Cassini, because guess what it's for?
Yeah, that looks like a very crusty, low poly.
Oh, there's actually a website for this. I've linked it.
Really? Oh my gosh. Okay,
Yeah,
gotta check that out after this.
That's where I got this from. So again, it's Galileo, Cassini, Uranus Orbiter and Probe, but for Neptune, it's an orbiter, an atmospheric probe, with a focus on Triton.
Wow.
Now, the thing about Triton is they would actually use it as kind of like a thing where they'd fly by it to look at the other moons, too.
Okay.
Because you're going to do Triton science anyway. So use Triton, go look at it differently, and then go look at, Nereid or Larissa or...
the other ones. Who cares?
And the rest.
Are here in Neptune's orbit, yeah.
Yeah, and as I talked about with the later Uranus probes, is the big thing here now is since we're discovering exoplanets roughly this size, we should probably understand how these ones work, so we can kind of guess what other Neptunes look like and behave as.
Right. Yeah.
And most of them are hot Neptunes. Okay, hot Neptunes.
As opposed to our lame, ugly Neptunes.
Yeah. This is cold Neptune because the hot Neptunes are really close to their stars because when we do Kepler, I'll talk about how we detect planets around stars. Mm-hmm. But the hot Neptunes are easy to find because they're really close to their stars, so they cause the wobble.
Yeah, they're really heavy, so they seesaw with it.
So launch would be in 2033 on SLS Block 2 with a Centaur on top of the EUS. So 3 hydrogen stages to kick it there in 20 years.
Oh, gosh.
And that's why these missions are hard to sell. Because
it just take forever.
You'd also need 3 RTGs to power this thing.
Jeez.
I don't think we even have that many left. We got to make more.
How hard is it to build an RTG?
You just need the money to do it. We have a few left. One's being reserved for Dragonfly that's going to Titan. Mm-hmm. I think we have one on reserve for the Uranus flagship mission. I think there's one more. We have 3 left. It's just got to build more. It's just got to spend money on doing that. Mm-hmm. We just need to do this. So it reach again 20. That's the hard sells. It takes 20 years to get there.
That's so long.
Yeah, but again, I would say that it's worth it. It's high risk because again, think of everything that broke on Galileo on the way.
Yeah, but to be fair, Galileo was made in the 80s. We have 40 years of technological advancement on that thing.
And it sat in a corner for a few years collecting dust.
Counting it, but yeah.
And it was, counted the dust. We still get a signal from it. Yeah, it's still there. Look at all that dust. Yeah. This will weigh about 3.5 metric tons, because again, it's just you gotta get there.
Yeah.
I'm not gonna repeat all the experiments. You can guess what they are.
It's your basic probe starter package.
Except for one addition on the atmospheric probe. a camera.
Ooh, taking blue pictures.
Yeah. But can you imagine getting pictures from the atmosphere of Neptune?
That'd be pretty hype. It would also probably be pretty boring. I imagine it's just going to be blue haze.
Oh, wow, it's blue. Look over there. Blue.
Blue. Oh, it's getting darker now.
Blue. Why are you blue? Or
blue.
Yeah.
Dabo dee dabo die.
I don't know what that's from, but okay.
Okay, I'm not going to explain it to you.
Good. So again, here's a diagram of the spacecraft. Shocking, it looks like Cassini.
Yeah, wow. Impressive.
Yeah. And here's the orbital path it would take. Coming in, you use Triton to do flybys to look at the system for 4 years. If you look at the color version of this image, it'll show you how each year will be divvied up for science.
But we don't have color, so...
No, we have 2 colors, FFA 134 and 22222.
Don't reveal our secrets. Those are trade secrets.
And remember to email for copyright claims. What's your email again?
My email is idon'tcare@uranus.com.
So the other 2 I looked at were Trident and Triton Hopper. So Trident is the New Frontiers discount version of Neptune Odyssey. So instead of orbiting Neptune, it would do a flyby of Neptune and Triton.
What's the point? We already did that.
Yeah, but it would have the atmospheric probe as well.
Okay, so it'd still see the blue haze.
Yep.
And just repeat Voyager.
Yeah. Voyager 3. It would launch on Atlas V 551, January 2029. It would do a flyby in September through October 2042. I learned this when I was reading about this mission, actually. So you usually do Jupiter gravity assists to get out here, but for Neptune, there's a 2-year window every 12 years for them to be really effective. So the last one was in 2016 to 2018, and the next one's in 2028 to 2030.
Oh, okay.
Yeah. So this is a diagram.
And it's launching right in that window.
Yeah, right in the middle of it. This is a diagram of it with like 5 pixels. Again, low budget here.
Mm-hmm.
So you can see that...
Can't afford all the pixels.
Yeah, again, saving money on this. You can see it's got all the instruments, atmospheric probe, propellant tanks. Make sure you have the check valves not erode on this one. That would be pretty disappointing.
Ideally.
Yeah, you get your 4 RTGs there. And then we're going to talk about the coolest one. Triton Hopper.
Ooh, it's got landing legs.
So this would go on with Neptune Odyssey, and it would land on the surface of Triton near the geysers, right? As you can see in the ConOps here.
Yeah.
It would, again, because the geysers are the interesting part of Triton that we know about.
Yeah.
It would land and take pictures, do surface sampling, and it would also collect some of the nitrogen, store it in a propellant tank, and then superheat it to use as thrusters.
Oh my gosh.
Yeah.
So it's self-fueling.
Yeah, so it would land, take pictures, take samples, take off, land somewhere else.
That is awesome.
Isn't that cool?
That is so cool.
That is a really cool mission. Again, flagship class, though. This is a very complex system, right? You got to scoop up nitrogen ice, even if you can do that, turn it into a liquid or a gas, and then use it as a thruster, right? That's pretty complex.
That is pretty complex, yeah.
That's why these missions cost $2 to $4 billion.
Yeah.
Now let's keep going. There's a few more I want to discuss. Don't worry, not that many. It's
Pluto.
That is Pluto. Isn't that cool?
That is awesome.
This is Pluto as of 10 years ago, because I'm old now.
It's already been a decade?
Yeah.
Oh my.
I remember because I was working water meters in June of 2015 when these images started coming in. I remember looking at them on the TV during lunch at midnight breaks. This is Pluto.
That's incredible.
What a beautiful place. And again,
Yeah.
New Horizons did a flyby.
Yeah.
What's another thing you notice about this? Based on
It's got an atmosphere.
Exactly. So I want to talk about the Kuiper Belt. So this is the asteroid belt for frozen things. This is for stuff that goes beyond Neptune.
Beyond.
Now, there's not really any solid plans for anything out past Neptune, There was a proposal for New Horizons 2. There's been proposals for these kinds of missions. China's working on their own Voyager-style program called Shenzhou.
Okay.
That's going to launch... It was supposed to launch, I think, this year or next year, but it got delayed because of COVID. I think by the end of the decade, they want to launch 2 of them. And they would go to the heliopause, which is basically the sun... it's pretty much where the sun stops being the dominant thing of interstellar medium, and it's the galaxy.
Oh, okay.
That area. The pictured here is called Interstellar Probe.
Okay.
And it's pretty much missions to go to the edge of the solar system.
That's pretty far.
As you can see, it would require a lot of RTGs, all 4 of them.
Yeah.
And during these missions, they'd also do flybys of things in the Kuiper Belt and the outer solar system because there's a lot of cool places to visit. Like Pluto or Quaoar. This guy.
Rings.
So Quaoar has a radius of about 545 kilometers. To put that into perspective, that's the distance from me to the International Space Station.
Okay.
About 340 miles across. Or 680 miles across total. It's sitting out at about 44 AU, which is really far away.
That's really far away.
It's orbit.
Remember, Neptune's at 30 AU.
Yep. Pluto's at like 35, depending on what time of year it is. It's got an eccentric orbit. It's actually closer than Neptune sometimes. Its orbital period is about 289 years. So Quaoar, if we were to observe it today, 289 years from now, it finally completed 1 orbit. Took you long enough.
Slow.
Now, obviously, Quaoar is interesting because it's got 2 rings. It's got a tiny moon named Weiwat. Oh, so Quaoar and Weiwat are part of the Tongva creation myth. Tongva are the Native American tribe in Los Angeles that used to be there.
Oh, okay.
Yeah. It's where JPL is. That's where they discover it. Based on observations, there might be surface water, frozen, from cryovolcanism, and methane.
Ooh.
Which means it might even have an atmosphere, like Pluto.
That'd be pretty cool. That's awesome. It's got the whole thing, right?
Yeah.
You got the rings, you got the moons, you got the atmosphere.
Behold, Saturn. Oh, and the reason I didn't look at any Saturn proposals is because most of them are land something on Titan, land something on Enceladus. And I think everyone agrees that going to Saturn is cool and worthwhile.
Yeah, that's a much easier sell than, hey, want to wait 12 years to look at the blue thing?
Yeah, you want to wait 12 years to look at Uranus? I read a study that looked at going to 3 potential trans-Neptunian objects. One's called Uni. It's large, but low density. It's got a moon. 1998 WW31. That one rolls off the tongue.
Yeah, World War 31.
Yep, got a lot of them. In 1998, too. Gosh, just keep cranking those out.
Yeah, we're doing the annual World Wars,
Yeah.
It's like iPhones.
Yeah, they just keep coming out every year, It's like Call of Duty.
Every year we gotta have a new World War.
Yep. This one's interesting because it's a binary system.
Ooh, okay.
Yep. And then Lempo, which is a triple system.
Wait, you can have a triple system?
You can have triple systems, yeah. Pluto has 5 moons. Technically, Pluto's a binary with 4 moons, if you want to look at it. I think Lempo it's the main body, and then it's got 2 moons that orbit each other.
Okay.
These are worth going to, as you can guess. These are worth going to. It'll just take 24 years to get to them.
It's just gonna take forever.
Yeah. Some other objects I think would be interesting would be Ixion, which is a large Plutino. It's one of the largest objects discovered in the Kuiper Belt. Orcus, so that's what's pictured here in all 12 pixels of it.
Mm-hmm.
It's large and it's got a moon, as you can see.
The smaller bright pixels.
Yep, that's called Vanth. It's J.D. Vance with a lisp. Eris, which, if you know your history of Kuiper Belt objects, is the reason Pluto is no longer a planet.
Thank you, Eris.
Do you want to know why?
Because it's bigger than Pluto?
Because it's bigger than Pluto. And it's got a moon.
That's the reason?
Yeah. Well, because then it's, okay, we discovered something bigger than Pluto in the outer solar system. Is that a planet? And then Mike Brown and those other guys said, yeah, but there's a whole bunch of objects that are Pluto-sized, like Orcus, Ixion, World War 31. Okay, so maybe we were wrong that Pluto's a planet.
And so that's why we got the dwarf planet designation.
Yeah, because for a while, Ceres was considered a planet.
Really?
Yes, if you look at some of the older astronomical charts, Ceres was considered a planet.
Dang, okay.
Yeah. So Eris killed Pluto and it's got a moon. And there's Haumea, which is football-shaped.
American football.
Yep.
Correct football shape.
The correct football shape. It's got rings and has 2 moons.
I mean, these are awesome objects.
They're worth going. The problem is, right now, with our current propulsion technologies, we just can't get there in a reasonable time frame.
Yes, but what if we could?
That would require the government to actually be functioning.
Okay, never mind.
So for a small donation of $16 billion, you too can explore the outer solar system.
A small loan of $16 billion.
We can afford that.
Yeah, that's easy.
That's good.
We can scrounge up $16 billion.
That's our Patreon goal.
Look, this is very simple. We start an AI company. Investors give us $100 billion. We spend 16 of it going to the outer solar system.
Yeah.
Easy.
So I'll go to Uranus. You'll go to Neptune. Subscribers will send those to the Kuiper Belt. They can go out there.
Yeah. Well, they'll go to the TNOs.
Yeah. The trans-Neptunian objects. Yeah.
Yep.
And that is Cool Space Probes I'd Like to See, Volume 1.
Yeah. Clap, clap, clap. Nice.
I made this image, actually. Because from the Neptune Odyssey website, it doesn't have a background, so I just took that. I put this in. Again, aside from the name, it's unfortunate Uranus has the worst name for a planet. Because
it has terrible branding.
It's terrible branding, but it's a really interesting planet.
It is.
I also really like the blue as well. I think it's a really pretty blue.
Yeah, it's sky blue.
And also the seasonality of it's pretty interesting too.
Well, yeah, it's sideways.
It's sideways, which is so cool. There's a Stephen Baxter short story called Earth 2. It's a sequel to Flood and Ark, where a human colony is set up on a planet that's on its side. And the people live on it. It talks about kind of what would the society be like on a planet like that.
That would be pretty cool. I bet they'd have interesting architecture.
Not really.
Well, never mind.
Yeah.
Screw that planet.
Yeah, screw those guys. Well, also, they didn't have much. In the book, the planet's like 1 billion years older than Earth. Aliens were already on it and strip mined it. So.
Oh.
Yeah, so everyone's stuck in the past there. They're stuck in like the 1400s technologically.
Losers.
Yeah. But again, these are cool space probes. Again, I just think those are interesting. It's just the problem is all these cost oodles of money.
Yeah, but again, all you got to do is start up an AI company. That's investors give you $100 billion, and then you use it as a disposable income.
Yeah. Buy an island. Explore Uranus.
Pretty simple.
Yeah.
But for now, I guess, no, never mind.
Happy Thanksgiving, everybody.
Happy Thanksgiving.
Happy Thanksgiving. So some future specials, I would just, as a kind of a teaser for what I want to do next year or the next few years. On the left, underwater
abyss?
Underwater habitats, actually.
Oh.
Ocean research is pretty interesting. It's a good space analog. This is called Tektite 2. It's actually a space station analog for a while.
Ooh, okay.
I think it also had the first all-female crew of an underwater habitat.
Congratulations. Nice job.
Yep. And on the right, high-altitude ballooning.
With incredible fashion.
Which is a mix of very silly things and very interesting science. And a lot of Minnesota.
Is that a child?
Yes, it is a child. Now, if this is Auguste Piccard's son, Jacques Piccard, he will go to one of the first people to go to the bottom of the Mariana Trench.
Okay. So people went high, he went low.
Yes. Yeah. Also, so as a spoiler alert, Auguste Picard, the guy here in the picture, is the namesake for Captain Picard in Star Trek.
Jean-Luc Picard.
Yep, that's how he got his name. He did a lot of high altitude ballooning. His brother did a lot of high altitude ballooning in Minnesota. His wife was one of the first female bishops of one of the churches. We'll talk about them when we do the ballooning special, because they did a lot of really interesting things.
Yeah.
It's all really interesting. Learning is fun.
I love learning.
Learning is good. So is eating at Thanksgiving.
Yeah, it's making me hungry. I want to have some turkey now.
Yeah, in the beginning of October.
Yep, definitely.
Happy Thanksgiving, everyone.
Probe Uranus.